Okay, so let's start with this Eskimo who slides down the igloo until eventually loses contact and then continues to fall in a sort of a parabola. We'll define an angle which tells us how far down the igloo he has slipped. Let's start by looking at how fast he'd be traveling. So if the igloo has a radius of r, then the height that he would have fallen is that little bit there, and that height is going to be r minus r cos theta, since this bit here is r cos theta. Okay, so that tells us then that the velocity that he's moving at, or v squared I'm going to use anyway, which is normally 2gh, that will be 2g times r minus r cos theta. Next thing is to look at the forces. So he'll have his weight, which is acting down, and he'll have the normal reaction from the surface of the igloo. If as he starts to lose contact, the normal reaction will become zero. So essentially we're looking for the point where he's still moving in a circle, but with only the radial component of his weight. So I'm going to split the weight into two components, and the radial component, given that this is theta, is once again mg cos theta. And that radial component will be supplying the centripetal force. Now, we've worked out already what v squared is. So I get m times 2g times r minus r cos theta divided by r. We can cancel some stuff out. We can cancel the m's, we can cancel the g's, and we can cancel the r's on the top of the bottom. So I get an equation for theta here, which is that cos theta equals 2 minus 2 cos theta. That tells me that cos theta equals 2/3. And from that you can work out theta. It's the inverse cos of 2/3. So if I just try and get that value, I suppose it's worthwhile. So that's 48.2 degrees.